Now, what is the last point? Hook joint. Okay. Hook joint analysis. Now, the first point is velocity ratio. Now, can find out the velocity ratio. It is the ratio of speed of driven shaft to the speed of driving shaft in terms of radian per second or RPM. Okay. Omega 2 upon omega 1 or m 2 upon n1 is equal to cos alpha upon 1 minus cos square theta sin square alpha. Now, what is this alpha? Anyone? Anyone tell me what is this alpha? Alpha क्या है?
Angle of driving shaft.
Okay. And driven shaft. The angle of inclination between the driving and driven shaft. Okay. Now theta is angle turned by driving shaft. Okay. Now in this way, if the speed of the driving shaft is given, angle of inclination of driving and driven shaft is given, and if you turn the driving shaft at an angle theta, you can easily calculate the speed of driven shaft. Okay. Now here, the second point is maximum and minimum speed of driven shaft. Okay. Now the
Hello, sir.
speed of driven.
सर स्क्रीन दिसत नाहीये तुमची.
हाँ सर स्क्रीन नाही दिसत आहे.
1 minute.
Screen आहे. Yes.
Is it visible?
Yes. Sir.
Yes, sir.
Yes sir.
Okay. Now the next point is the maximum and minimum speed of driven shaft. Actually, in old syllabus there will be a numerical on this hook joint. Okay. Now the new syllabus there is no numerical. That time these terms are very important. Now you have to find out the speed of minimum or maximum speed of driven shaft, or you have to find out the fluctuation of speed. Okay. Now only go through this formula. Okay. There is no numerical on this. Now the minimum and maximum speed of driven shaft. The speed of driven shaft is denoted by omega 1 or omega 2. Tell me the notation.
Driven shaft omega
Omega 2.
2.
Now can find out the minimum and maximum speed. We know the speed ratio. Okay. Speed ratio is omega 2 upon omega 1 is equal to cos alpha upon 1 minus cos square theta sin square alpha. Okay. Now can find out the maximum speed of driven shaft. To maximum, when you will get the maximum omega 2 from the given formula. Maximum speed कैसे मिलेगा? Anyone?
When the denominator is less, like.
Denominator is less means what is the value of cos theta means how much angle turn by this driving shaft. Theta cos theta कितना होना चाहिए? 0 or 1? 0 और 1 cos theta कितना होना चाहिए? You will
0.
get omega 2 maximum. How much?
0
1
Cos theta 0 हो गया तो now in denominator there will be 1 ना. If the cos theta
Yes,
is 1,
yes, yes.
cos theta 1 रहेगा तो denominator is less than 1 means in that case the numerator, the right hand side numerator is maximum. ज़्यादा चाहिए. Okay. Means in that case suppose you have to consider the cos theta is equal to 1. Now what is the angle turned by this theta? Theta angle कितना होना चाहिए? Theta is equal to how much? If you want to cos theta is equal to 1, now theta is equal to how much? Pi na 180. 0 180, correct na? It's like this. Okay, omega 2 is maximum when denominator is minimum. Denominator कितना चाहिए? मुझे कम चाहिए तो means it is less than 1. उसके लिए क्या चाहिए मुझे? Cos theta is equal to 1, not 0. Okay, means cos theta is equal to 1, that is theta कितना होना चाहिए? 0 pi 2 pi like this. Okay, maximum speed of driven shaft you will get the angle of turn of driving shaft is 0 180 360 like this. Okay, at this location you will get the maximum speed of driven shaft. Okay, you have to put the value cos theta 1 in above equation, you will get the cos alpha upon 1 minus sin square alpha. Is it right? We know the 1 minus sin square alpha means 1 minus sin square alpha is equal to what? Cos square alpha, correct? Hello?
Yes.
You will get here cos square alpha, 1 cos square alpha get cancelled, means you will get the omega to maximum is equal to omega 1 upon cos alpha. Okay, what is the formula to find out the maximum speed of driven shaft? Omega 1 upon cos alpha. And omega 2 is minimum. When you will get the omega 2 is minimum? Omega 2 minimum कब मिलेगा मुझे? When the denominator is
मैक्सिमम
means
Max.
cos theta कितना होता है मुझे? 0. 0 means 1 आएगा denominator, not less than 1. 0 cos theta 0 आने के लिए मेरा एंगल कितना चाहिए? pi by 2 to 3 pi by 2 means 90 to 70 like this. Is it right? Means the speed of the driven shaft is minimum at the location क्या होना चाहिए? Angle of turn is your 90 degree or 270 degree. Now these angles are very important. By using this angle, you have to draw the polar diagram. Okay, polar diagram draw करना है. Okay, maximum angle of turn, sorry, maximum speed of driven shaft, you will get the turning angle of driving shaft is your 0 degree होना चाहिए, 180, 360 like this. और minimum speed कहाँ पे मिलेगा? Angle of turn of driving shaft is your 90 degree, 270 degree like this. Okay, I have to put this cos theta is equal to 0 in the above equation. Velocity ratio you will get here in denominator you will get the 1 minus 0 means 1 means omega 2 minimum is equal to omega 1 cos alpha. Okay, omega 2 minimum is equal to omega 1 cos alpha. Now these are the two conditions. Okay, you will get the maximum and minimum speed. Got it, all of you?
यस सर
Yes.
Minimum and maximum speed of driven shaft. All of you write down only the formula. Maximum and minimum speed of driven shaft. Omega 2 max, you have to write down omega 1 upon cos alpha. Omega 2 minimum is equal to omega 1 cos alpha. Only note down the formula.
हॅलो सर, अँगलचं परत सांगा ना एकदा.
हेलो हेलो
Yes, sir.
आज अरे नेटवर्क का प्रॉब्लम है थोड़ा. आवाज आ रहा है ना? हेलो
Yes, sir. अभी आपको
वन मिनट है वन मिनट. हेलो स्क्रीन दिख रहा है ना सबको?
हाँ सर दिख रहा है.
आवाज आ रहा है ना?
Yes, sir.
Find out the maximum and minimum speed by using this formula. Okay. Now next is the condition of equal speed. Now where you will get the equal speed? This omega 1 is equal to omega 2. The speed of the driving and driven shaft are equal. Now you will get the condition of the equal speed. Only see the formula. There is no need to write this derivation also. Okay. Tan square theta is equal to plus minus under root of cos alpha. Okay. You have to find out the angle of equal speed. Tan square alpha theta means theta you will get here. Under root of cos alpha. Alpha is the angle of inclination of the driving and driven shaft. Once you will know the angle of inclination of driving and driven shaft, you will get the angle of the equal speed. Okay. Now maximum fluctuation of speed is the one more point. Okay. Now only listen because there is no numerical on this. Fluctuation of speed means what? Anyone?
Speed is not constant.
Speed is not constant. Actually, if you observe here, the speed of the driving shaft is constant, but when we vary the speed of the driving shaft, there is a fluctuation in the speed of the driven shaft. Now, if you see, you will get the maximum speed of driven shaft and minimum speed of driven shaft. There are two separate formulas. Means you will get the two separate values. Means there is a variation. The speed of the driven shaft get varied from minimum to maximum for the one constant speed of the driving shaft. Now that is known as a fluctuation of speed of the driven shaft. You can find out the fluctuation or maximum fluctuation of speed of driven shaft by using this formula. Q is equal to omega 2 max minus omega 2 minimum. Means you find out the omega 2 maximum, the formula is here. Omega 1 upon cos alpha and omega 2 minimum is your omega 1 into cos alpha. जो भी difference रहेगा, now it is a fluctuation of the speed of the driven shaft. Got it? Now next is a very important point, polar diagram. Now the polar diagram. Now, is it visible to all? Now there is a 2 marks question also.
Yes.
For test, unit test, or 5 marks question in the university question paper. Explain the polar diagram of hook joint. Is it visible?
Yes.
Okay, now what is this polar diagram? Now it is a diagram showing the relation between speed of the driving and driven shaft. Okay, there is a circle and there is a ellipse. Now tell me, the circle shows the speed of driving or driven shaft, and ellipse shows the speed of the driven or driving shaft. क्या रहेगा? Now circle represent speed of
Driving shaft.
correct driving shaft, and speed of the driven shaft is represented by this ellipse. Okay, we know the maximum speed. Where you will get the maximum speed? The cos theta is equal to 1. Okay, means when you will get the cos theta is equal to 1, थीटा कितना होना चाहिए था? कंडीशन फॉर मैक्सिमम स्पीड थीटा कितना चाहिए था मेरा?
0 pi 2 pi.
Correct, 0 pi 2 pi means like this. Here you will get, where you will get this maximum speed at angle or at which location? 1 2 3 4 maximum speed of driven shaft. Here circle shows the constant speed of driving shaft. Okay, now there is a variation in the speed of the driven shaft. एक तो maximum रहेगा, minimum रहेगा, otherwise equal रहेगा. Okay, where you will get the maximum speed when the cos theta is equal to 1 means theta कितना चाहिए मुझे? 0 चाहिए, pi चाहिए, 2 pi by. Okay, like this. Means एक तो 0 degree चाहिए, 180 degree चाहिए, or 360 degree. Like this means at the location 1 and 2 you will get the maximum speed of driven shaft. Means when your driving shaft is at an angle 0 and 180 degree, you will get the maximum speed of driven shaft. Okay, now when you will get, or where you will get the minimum speed of driven shaft? What is the condition of minimum speed of driven shaft? Cos theta is equal to 0. Means theta कितना चाहिए मुझे? Pi by 2, 3 pi by 2 means 90 degree 270 degree like this. Means when your driving shaft turn at an angle 90 degree or 270 degree, you will get the minimum speed of the driven shaft. Now here is the minimum speed of the driven shaft, omega 1 minimum. Okay, omega 1 minimum. Or sorry, here is the by mistake there is omega 1. Okay, now here is the omega 2. Here is the omega 2. This is the omega 2. Okay, you will get here minimum speed of driven shaft. Got it? And where you will get the equal speed? Anyone from figure? Equal speed कहाँ पे मिलेगा?
6 and 8. 6 and 8.
Now where this
0.5678.
correct. Where this ellipse and circle intersect, you will get the equal speed. Means यहाँ पे 5, 6, 7 and 8. Means the angle कितना रहेगा वहाँ पे? Theta angle कितना होना चाहिए? This much. Means it is 45. Now this one is 90 plus 45. This one, okay, 180 degree plus 45. This one, 270 degree plus 45. Is it right? Now at this angle of rotation of this driving shaft, theta, you will get the equal speed of the driving and driven shaft. Omega 1 is equal to omega 2. यहाँ पे क्या? Omega 1 is equal to omega. Right. यहाँ पे omega 1 equal to omega 2. Okay. Now the diagram showing the variation of the speed of driven shaft with respect to driving shaft is called as a polar diagram. Now during one revolution of the driving shaft, means theta, omega 2 max occur, means maximum speed of driven shaft occur at a point 1 and 2, means angle कितना रहेगा? 0 degree 180 degree. Okay. Now omega 2 minimum or minimum speed of driven shaft you will get at a point 4 and 3, means angle कितना रहेगा मेरा? 90 and 270 degree. And omega 1 is equal to omega 2 occurs at a point 5, 6, 7, 8. Means angle कितना रहेगा? 45, 135, 225, 315. Okay. Now these are the various locations of the angle turned by the driving shaft. You will get the maximum, minimum and equal speed of the driven shaft. Got it, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Now this is very important point. The exam point of view, test also, there is a small question in the test also. You have to draw this polar diagram, or suppose there is the MCQ. What is the angle of turn of this driving shaft? What is the angle of the turn of the driving shaft? You will get the maximum speed of driven shaft. There are the different options are there. Suppose there is a 0 degree, 270, 135, 45. Okay, like this. Okay, only we have to draw this figure. Don't write this description. Write down the polar diagram and draw figure. Draw freehand. The last point. You can find out the angular acceleration of the driven shaft, which is denoted by alpha to maximum. Now there is a formula. No need to write this formula. Okay, now see one more point is here. Double hook joint. Like this. This is the double hook joint. Okay, done all of you? Okay, now what is this? What is this double hook joint? Anyone? क्या रहेगा double hook joint?
सर तो सी ड्रिवन शाफ्ट असेल ना? Hello. Hello. Now here, what is this double hook joint? क्या है यहाँ पे? Anyone? Now there are two hook joints. Now here, actually, if you observe, when the driving shaft rotates with the constant speed, there is a variation in the speed of the driven shaft. Okay, means the velocity ratio is vary from minimum to maximum as per your speed of the driven shaft. Suppose the speed of the driven shaft is maximum, then you will get the maximum velocity. So speed of the driven shaft is minimum, then you will get the minimum velocity ratio. Means there is a variation in the velocity ratio. For getting the constant velocity ratio, you can use the intermediate shaft, and at the both end of the intermediate shaft there is a hook joint. Okay, now यहाँ पे hook joint है. Here is the one joint, and here is the one joint. Now there are two hook joints, and at one hook joint there is a driving shaft is attached, and another hook joint there is a driven shaft is attached, and the angle of inclination of both are same with the intermediate shaft, like this alpha. And because of that, what happen? You will get the constant velocity ratio. For getting the constant velocity ratio, double hook joint is used. Okay. Hello, समझ में आ रहा है ना? So
Yes, sir.
now, the last point of this module, double hook joint. Now, double hook joint is used to for getting the constant velocity ratio, because there is a variation in the speed of the driven shaft. Because of that, you will get the variation in the velocity ratio. For getting the constant velocity ratio, you can use the intermediate shaft, and at the both end of the intermediate shaft there is a hook joint. These are the two hook joints. That's why you can see it is a double hook joint. एक hook joint को क्या किया है? Driving shaft is attached, and another hook joint there is a driven shaft is attached, but the angle of inclination is of both are same, alpha. Yeah.
So
With the
it is
intermediate.
it is used to maintain the constant speed.
To maintain the constant speed.
Okay.
Okay, done all of you? Okay, now here we end this model number 2. Okay, now in model number 2 there are different points, and it is a theoretical model here. And that first one is a pantograph, then straight line generating mechanism. In that exact straight line generating mechanism is your Euler mechanism, and Hertz mechanism is your approximate straight line generating mechanism. उसमें कौन सा था? Grasshopper mechanism, Robert mechanism, and TB chip mechanism. Now from that, grasshopper and TB chip is very important. Okay, next, steering gear mechanism. In that, condition of correct steering gear mechanism is very important, and Davis steering gear mechanism and Ackermann difference. Okay, next is a hook joint. In that, velocity ratio derivation is very important, and polar diagram. Okay, these are the important points from this model number 2. I understand all of you. Any doubt?
No, sir.
Yes or no? Okay. Saurin, आज join नहीं हुआ आज. ठीक है. Okay. Now today I will send the PPTs of basic dynamic and special mechanism. Okay. I will start the next module. कुछ डाउट नहीं है ना? आदित्य, रोहित, रोहित हेगड़े, पार्थ, हाँ ऋषिकेश. Is there any doubt?
Is there any disadvantage of this mechanism?
Hook joint. Hello. If there is a joint, there is always friction takes place, wear takes place. Okay,
Oh, yeah.
there is a loss of power.
Okay, sir.
So practical example of double hook joint.
Practical example of double hook joint, you have to see. If you see the tractor. Tractor.
Yes, sir.
Yes.
क्या बोलते हैं उसको, खेती में काम करते समय ना पीछे एक रहता है, ऐसे एक रॉड रहता है, उसको दो तरफ हुक जॉइंट रहता है, ध्यान में रखना. एक ट्रैक्टर के यहाँ पे कपलिंग को अटैच करते हैं और दूसरा जो पीछे लगाते हैं ना वहाँ पे अटैच करते हैं. और पावर ट्रांसमिशन का जहाँ पे भी डिवाइस रहेगा ना, यू विल गेट दिस वन. इफ यू वांट द मोर एक्यूरेसी इन द वेलोसिटी रेशियो, यू कैन यूज दिस डबल हुक जॉइंट. क्या क्या इंटरमीडिएट शाफ्ट डाला है यहाँ पे, बाकी कुछ नहीं. ओके, अगर आप लैब अगर कॉलेज शुरू हो गया तो हमारे पास यही है डबल हुक जॉइंट. Okay, now we will start the next module. Now all of you listen, the notebook is very important for this module. Module number 3, velocity and acceleration analysis. We will see the two methods. One is the ICR method and another is your relative velocity method. Got it? Now it is a totally graphical method. Today we will finish the theoretical part. From next lecture we will start the numericals. Okay, when we start the numerical, the blank papers or any paper you can use here. Okay, A3 size, A4 size. Okay, but the pencil, rubber, scale or roller scale is very important for that. Roller scale important is ध्यान में रखना. ठीक है? Rounder is very important. You have to find out the velocity analysis or velocity by graphical method. That's why we require this. Okay, now here we start here first of all. See the introduction or outline for this module. First of all, we will see the introduction of instantaneous center of rotation. Now, what is this ICR, or how we will get this instantaneous center of rotation of any link? Because when the mechanism moves, the mechanism move हो जाएगा. Now there are number of links are there, and that links are also move with respect to each other. When that links move in curve path, now there will be one of the center of that link. Now that center you have to find out here. Okay, next method for determining the velocity of point on a link. Actually, in link, suppose you have to consider the midpoint of the link, you can easily find out the velocity of that link. There are different methods. From that, we will see the two methods only, ICR and relative velocity method. Okay, now next is velocity of a point on the link by ICR method. Now to find out the velocity of any point or link by using ICR method, we will see how to find out it. Then properties of ICR or instantaneous center of rotation की properties क्या रहती है? There are two properties. And number of ICRs in a mechanism. Now, how to calculate the number of ICRs in the mechanism is a very important point. Okay, once you know the number of links in the given mechanism, you can easily calculate the number of ICRs in a mechanism. कितने centers रहेंगे, center of rotation. Then types of ICRs. There are three types of ICRs we will see. Okay, accordingly, you have to locate that ICRs in the given mechanism. Then location of ICR. Next point. Now there are different methods, or you can visualize that methods. Okay, if you see the mechanism, you will get clear idea. Now, where you have to locate this ICR? Then Kennedy's theorem. Now, some of the ICRs you cannot get this by inspection. Okay. Now that ICRs you have to find out by using this Kennedy's theorem. And next is a method of locating ICRs in a mechanism. Now we will see the method how to locate the ICR in a mechanism and how to find out the velocity of a particular link or any point on the link by using the ICR method. Now this is the last one. Okay, got it? Okay, these are the various points we will cover in this module. Can we start?
Yes, sir.
Here from this, don't miss the single lecture. Velocity analysis and acceleration analysis. Suppose एक problem miss हो गया तो आपको next time समझ में नहीं आएगा कि how to solve this problem. Okay, and the practice is very important for this. Okay, now first one, suppose you have to consider here the link ABC in the figure. Okay, suppose consider this is the link AB. This is very simple concept how to find out the ICR and what is this ICR. Okay, suppose I will change the location of this link. Suppose the link is, or I will move this link, and you will get the new position of the link is here. A1 B1. How many motions takes place when the link moves from AB to A1 B1? Anyone?
Two motions.
No. Which are the two motions?
Linear and rotational. Linear
Linear
and
and
rotational.
correct. Now suppose it moves from A to A1
Rotational.
like this. Rotational. Correct. You will get here. Suppose I will draw here parallel line. Suppose B dash. Now this is your translatory motion or linear motion. Okay. Now next is your rotational motion. There are two motions. When any link moves from one position to another position, there are two motions takes place. One is a linear motion and another is rotational motion. Correct? Any link from the mechanism moves from one position to another position. There are two motions takes place. One is linear and
Rotational.
another is translatory motion. Correct?
Yes.
Okay. But now it is invisible actually. If you consider here, suppose हमने यहाँ पे observe किया, suppose यहाँ पे थे और यहाँ पे link मैंने move किया. Now we do not consider the translatory motion. Actually, we consider it is a linear, rotary motion. Correct? Yeah. In practical, we consider only one motion, and it is a rotary motion. Okay, means what happened? We consider the link AB moves from A B to A1 B1. We consider only one motion. Now that motion is your rotary motion. Okay, when there is a rotary motion means that link moves with respect to one of the point or the center. That link moves with respect to one of the center. Now that center is known as the instantaneous center of rotation or ICR. That center is known as a center of rotation of that link. Okay. Hello.
Yes, sir.
Yes, sir.
क्या इतने यहाँ पे मोशन कितने लिंक ए बी की मोशन दो है इन दैट इट हैज अ फर्स्ट मोशन ऑफ translatory motion and then next is your rotary motion. It is a combined two motions, translatory and rotary motion. Okay, but in practical we use only the one. It is a rotary motion, or this combined motion is as a considered as a rotational motion about the center, and that center is known as the instantaneous center of rotation, or we can say it is a virtual center of that rotation of that link. That center is known as the instantaneous center of rotation. Okay, ICR. I for instantaneous, C for center, and R for rotation. Okay, now can find out this instantaneous center of rotation of that link. Okay, this is very important point. Find out the instantaneous center of rotation of the given link. Suppose you have to consider the AB moves from A1 to B1. You have to join this A to B1 and A to A1. Now this is the velocity of A with respect to a fixed point, suppose O, यहाँ पे fixed point है O, okay, and this is the velocity of B. This is the velocity of B. This B की motion हो रही है यहाँ पे with respect to, or it is a linear motion from B to B1 and A to A1. Okay. Now to find out the instantaneous center of rotation of AB. For that you have to find out, or you have to draw here perpendicular bisector to this BB1 and AA1. Suppose I will draw here perpendicular bisector to this AA1. You will get this line. Okay. And perpendicular bisector to this BB1, you will get this line. Where these two lines intersect or projections intersect, now this center is known as the instantaneous center of rotation of the link AB. Okay, you have to join this AA1, it is the velocity of A, and BB1, it is the velocity of B. Now you have to draw the perpendicular bisector to this AA1 and BB1, where this intersect, you will get the ICR of center of rotation of the link AB. Got it? Hello?
Yes, sir.
Means
Yes,
you have
sir.
means you have to draw perpendicular to the velocity of a point on a link. Suppose you have a point here, मैंने suppose C. Okay. Suppose C moves from C to C1. I have to join here. Through this, you have to draw this perpendicular. You will get the instantaneous center. Okay. Suppose the link AB moves here. A to B2. A to B2. I have to join this and draw perpendicular bisector. Suppose ये यहाँ पे. Now you will get here like this I1. Like this, the position to position, the instantaneous center of rotation get changes. Okay.
Yes, sir.
If you draw the locus of
Yes,
this
sir.
instantaneous centers for various positions of this link AB, you will get this centroid. Okay, it is termed as a centroid. Now this is the first point. Okay. Now this is link AB moves from A1 to B dash or A1 to B1. There are two rotations. With translator and rotation, you have to consider it is a rotational moment. Now we have to join this A to B, B1 and A to A1 and draw perpendicular bisector. Okay, where this intersect, you will get this I as an instantaneous center of rotation. Okay, now this is the first point. Now see the next one is a method of for determining the velocity of a point on a link. Actually, there are two methods. One is the ICR method and another is a relative velocity method. Method to find out velocity of a point on a link. Okay, now suppose we have to consider here the link AB. Again, take down the same link. This is very important point. Now this is the A and this is the B. How to find out the velocity of this link or any point on this link? Here, suppose velocity of A is known here. Velocity of A is equal to suppose x. Now velocity of A is known in magnitude and direction. Now direction is here towards the right hand side and magnitude is your x, and velocity of B is known in velocity of B is known in direction only. Velocity of B is known in direction only. Suppose here is the velocity B. Got it? Okay.
Now I have to find out the velocity b magnitude. Velocity of b is equal to how much? By using the ICR method. I don't understand what is the problem.
Yes, sir.
Velocity of A is known in magnitude and direction. Magnitude is x and direction is shown in figure. And velocity of B is known in direction only. You have to find out the magnitude by using ICR method. How you will get the ICR? You have to draw the perpendicular to the velocity of the respective point. Correct? Means in the same figure you have to draw a perpendicular. You have to draw a perpendicular to this velocity A here. Okay, and you have to draw a perpendicular to the velocity b here. Where these two intersect, you will get the ICR of the link AB, instantaneous center of rotation of link AB. यहाँ पे मिल जाएगा. What it?
सर बाइसेक्टर का निकालना होता है ना, आईसीआर बाइसेक्ट करना पड़ता है पहले.
No. You have to draw the velocity at the perpendicular. Actually, you have to draw the velocity to the perpendicular to this. Line perpendicular to the velocity of the respective point. If you see the previous figure, यहाँ पे अगर देखा हमने, not here, in last case, is it visible? Now A moves from A to A1 means this is the velocity of A. Okay, the velocity of A. From this, you have to draw the perpendicular bisector. We know the distance traveled by this A to A1, B to B1. Graphically, suppose we draw here. मेरा A to A1 यहाँ तक गया, B to B1 यहाँ गया. You will get the exact location. If you don't know this A to A1 position of A1 and B1, how can draw this? How you can find out the ICR? Okay, suppose A1 और B1 की position ही पता नहीं है. How can draw this? I have to use this method. Okay, समझ में आ रहा है? You have to draw the perpendicular to the velocity A and velocity B. I understand? In previous case,
Yes,
we
sir.
know the location A and B. A1, B1 पता था मुझे, इसलिए you have to draw the perpendicular bisector. In this case, we don't know the location of A and B or new position of the AB. You have to draw the perpendicular to the velocity A and perpendicular to the velocity B. Where it intersects, you will get the ICR. Means इस point के center के about A row तेरा link AB move हो जाएगा. Means like this. ऐसे. Now this is the center of rotation of the AB. Okay. Now we know the velocity. How can find out the velocity? Anyone tell me the formula of velocity? V is equal to
Distance upon time.
R into omega. Is it right? General formula to find out the velocity. V is equal to R into omega. Is it right?
Yes, sir.
Now
Yes,
see the
sir.
same figure you have to consider here. Suppose velocity of A is equal to कैसे लिखेंगे यहाँ पे? Velocity of A is equal to R is radius of rotation of that point from the center. यहाँ पे correct IA. R is your IA into omega क्या आएगा? Omega किसका? The point, the link on which the A is located. Angular velocity of the link AB. Correct? That's right. Omega is the angular velocity of that link on which your point is located. A कहाँ पे located है? AB पे. Means omega AB. Now same velocity B कैसे निकालेंगे फिर? Velocity B is equal to radius क्या आएगा? I
IB.
IB. Omega.
IB omega AB same. Correct? Omega AB. Suppose I will write here, therefore, I will write here velocity B मुझे निकालना है. Suppose velocity B or you have to write down velocity A upon velocity B is equal to क्या आएगा? Velocity A upon velocity B is equal to what you will
I
get here?
into IB into omega.
IA upon IP.
IA upon IB.
Omega.
A upon IB.
IB.
Correct. क्योंकि A omega B cancel हो जाएगा. Omega AB. So you will get here velocity A upon velocity B is equal to distance IA. Now this IA is your distance. You have to measure it by using a scale. You have to put here. IB you have to measure and put here. जो भी unit रहेगा मीटर mm cancel हो जाएगा. Okay. Velocity A is a suppose velocity A is x. मुझे x पता है यहाँ पे. You can easily find out velocity B. Correct? Is it right?
Yes.
Yes,
You
sir.
have to measure ये डिस्टेंस मुझे मेजर करना है बस mm और सेंटीमीटर और मीटर में. वेलोसिटी ये मुझे पता है, ठीक है. यू कैन इजीली फाइंड आउट वेलोसिटी भी. Okay. Similarly, suppose any point take down here, suppose C लिया मैंने. You have to find out the velocity of C. How can find out the velocity C? We don't know the direction or direction and magnitude. How can I find out the velocity C? Anyone? कैसे आएगा velocity C? क्या करेंगे? You have to join this C point to this center of rotation. You will get this radius, and you have to draw the perpendicular to this. You will get the velocity. Direction मिल गया मुझे. Is right? Correct? Velocity कैसे निकालेंगे हम यहाँ पे velocity can find out the velocity. Anyone? Velocity upon velocity is equal to क्या आएगा फॉर्मूला?
IA upon IC.
A is equal to IA upon IC. Correct. IA upon IC. In this way, you can easily find out the velocity of any point on the link. If you know the center of rotation I of that particular link, you can easily find out the velocity of that link, and that ICR or the center I you have to find out graphically. And there is a method. Now that method is known as ICR method. Okay, understand all of you?
Yes, sir.
Doubt nahi hai na? Once you will get the one problem, you will get the clear idea. Okay, I will take a one problem, then you will get the clear idea. Now it is a starting. Okay, that's why it is very hard to understand. Okay, done. Don't write anything. Okay. समझ में आ रहा है कि नहीं?
Yes, sir.
ऐसे बीच बीच में बोला करो थोड़ा, मुझे समझ में आता है कि आप सुन रहे हो.
Okay, sir.
Yes, sir.
Yes, sir.